Okay, we have the question of just how sure we are that DCA is actually less than DAC. DCA, according to our 90% stab, which is very approximate, gives us a range that doesn't differ a whole lot from the range that we have for DAC. This is going out from C to A. This is coming in from A to C. Coming in from A to C, the range is shifted over about 5/1000ths of a mile, about 5% of a tenth. But there's still lots of room for possible overlap between these ranges. So what we have, even though we're maybe 90% sure of these ranges, of this range and this range, just using the range for the whole trip, we can't be very confident. We're not 90% confident that this one's really bigger than this one, or that, and certainly not that the difference is 0.005 miles, about 26 feet. So intuitively, in answer to the question, how sure, these numbers look fairly convincing. So we're reasonably sure that this distance is less than this one. But I put down here, reasonably, but don't bet the farm, okay? You're not going to invest heavily in the idea that this distance is less than this distance. You're not going to take a big risk on this idea, okay, unless you're very, very speculative. And then a question I didn't write down, but I just make the statement. We would need at least hundreds, perhaps thousands of observations at this level of measurement with tenth of a mile increments to be confident within a few feet. There are, of course, other ways to get the results. We could use more precise measuring instruments. We could use a measuring wheel and just walk from one point to the other and get pretty good results. And there are things we can even do with the odometer if we're clever, looking at where the odometer is on different trips when it makes the change, although that can be a little tricky because if you try to read the odometer and also keep the car on the road, you have to make some compromises. And even then, if you're looking at the odometer when it changes, you're not looking at the side of the road. You can't really tell that much. I've got it down pretty close, and I'm pretty sure it's somewhere between a difference of 50 and 125 feet, but that's still quite a wide range. It certainly doesn't allow me to estimate the diameter or the area of that roundabout, at least not in any very meaningful way. Now, just as a brief addendum, let's say we knew that this distance was 65% of the distance around the roundabout, and this is 0.35 of the distance. So that would be 65% of the circumference of our path. If the circumference of our path all the way around the roundabout is C, then this would be 0.65 C and this 0.35 C. Okay? Now, if we somehow knew that, and we knew, according to our estimate, that the difference is 26 feet, then what's the radius of the roundabout? Or what's the diameter? Or what's its area? Okay? Well, if we find the radius or the diameter or the area, or for that matter, the circumference, we can determine all those others. So if the difference is 26 feet, how can we determine the circumference? Well, it's fairly simple. That would mean that 0.65 C minus 0.35 C equals 26 feet, which means, just doing a little algebra, that 0.30 C equals 26 feet, so that C equals 26 feet over 0.30, which is approximately, and very ballpark, is more like 87, we'll say 90 feet. Remember that that 26 has been determined by a very uncertain process. Okay, so if the circumference is 90 feet, then what's the area of the roundabout, or at least what's the area inside the circle that I would travel if I drove around the roundabout. What's the diameter? What's the radius? What's the area? Well, we would figure that the diameter would have to be something around 15 feet. And if we look at the roundabout, we know that's ridiculous. So the radius and the area would also be ridiculously small. The roundabout is much bigger than would be indicated by this result. Also, these factors, 0.65 and 0.35, haven't been determined by any measurement, any good measurement of the roundabout, but it's clear that we go significantly further coming in than we go when going out, so these are probably not too far off. Bottom line, our analysis gave us an estimate of the diameter of the roundabout, the circumference of the roundabout, diameter, and so forth, the difference between the two paths, but a lot of uncertainty involved here. The overlap could be a lot bigger than this predicts, and we can't really draw any good conclusions based on just 23 measurements of distances coming in at the 1/10 of a mile increment and going out at the same increment. We would need, at that level of resolution, hundreds, perhaps thousands of observations to get anything resembling a good result. However, if we had an odometer that was set up sensibly to measure, let's say, hundredths of a mile, we could do much, much better. And in fact, we can find cars that have the old kind of rollover odometers that show you where you are between 2/10 of a mile, instead of the more modern odometers that only flip over every 1/10 of a mile and give you no idea where you are between 1/10 and the next. So using older equipment, we could get much better results. So I've put this statement up here: the rolling odometer could vastly improve estimates. User bias, though, would become a factor. So I'm pretty confident that with a rolling odometer, I could estimate this distance, give or take 10% of the distance, with an equal number of in and out observations. But that in estimating between the tenths, I would have some tendency to have certain types of misestimates more commonly than others. So there would be a limit to how well I could do this. However, those biases would tend to smooth out, would tend to cancel each other in a series of roughly 20 estimates in each direction, because the odometer would be at different points between the tenths with each reading. Now, I've extrapolated enough on this situation, and I'm not going to get into that. But those are interesting ideas, interesting questions, and interesting reflections on the nature of measurement and the nature of uncertainty. So I'll leave you with a phrase to ponder. What's the nature of measurement? How do we get accuracy and precision in measurement? That question is the real purpose of this problem and everything that comes from it.